Hi, welcome to the video lesson 7.2, Triangle Congruence Theorems. So in our last lesson, we looked at drawing different triangles based on information given. In this section, we are looking at which of those specific pieces of information, or in this case, which theorems, result in congruent triangles. These theorems are also some of the main theorems that show up in proofs, especially in higher level geometries for building off of shapes based around triangles. So we're going to look at 4 different theorems to start, which are kind of our main triangle congruence theorems. The first one, side-side-side congruence theorem, or SSS, says if in 2 triangles, 3 sides of one triangle are congruent to 3 sides of the other, then the triangles are congruent. So if you look at the 2 triangles to the right, MNO and WYX, by matching up corresponding parts, we can write the congruence statement here. Triangle MNO is congruent to triangle WYX. So it doesn't matter which way we would name it. If I would name it ONM and XYW, as long as the corresponding parts are in the same order, meaning M with W, N with Y, and O with X. The next theorem is side-angle-side congruence theorem, which states if in 2 triangles, 2 sides and the included angle of one are congruent to 2 sides and the included angle of the other, then the triangles are congruent. So remember, an included angle is the angle that is in between the 2 sides or the vertex or vertices of those sides. So if we look, side AB and side AC have the included angle of A. So in this case, side angle side, triangle ABC is congruent to triangle DEF. And again, this piece right here is simply known as a congruence statement. Then we have angle-side-angle congruence theorem, which states if in 2 triangles, 2 angles and the included side of one are congruent to 2 angles and the included side of the other, then the triangles are congruent. So looking at the example to the right with the 2 triangles here, our congruence statement would be triangle HIJ is congruent to triangle LMK. And our last congruence theorem for these first 4 is the angle-angle-side congruence theorem. So if in 2 triangles, 2 angles, and a non-included side of one triangle are congruent respectively to 2 angles and the corresponding non-included side of the other, then the triangles are congruent. And the key is that piece of the corresponding side, so you have to make sure that they match up. So for example here, RS corresponds with UT, and they are congruent. So in this case, angle, side, triangle QRS is congruent to triangle VTU. So a couple things looking at applying these. Write a congruent statement and state the theorem that justifies they are congruent. So if you look at examples A, B, C, D, E, and F, the congruence statements are on top and the theorems are on bottom. The theorems you can just abbreviate to the 3 letters. So looking at A, we have vertical angles of C, then we have side AC and CE, and then angle A and angle E. So in that case, it would be angle, side, angle because the side is in between the two angles on both. Looking at B, triangle EGF is congruent to triangle EGH by side, angle, side. They both share that side, EG. Then G on both is a right angle, and then side GF and GH. If we're looking at C, we have triangle LMK congruent to triangle IMJ by side, side, side. In D, they gave me two sides and an included angle. So by side, angle, side, triangle XWV is congruent to triangle YZA. In E, we have two angles and a non-included side. So that would be angle, angle, side. So triangle OQN is congruent to triangle OQP. And the last example for part 1, in F, we have angle, side, angle with the included side in between the two angles. So triangle RUT is congruent to triangle TSR. So example 2, everyone's favorite thing, starting to prove these ideas. Now in this image, it was rather easy because they gave us a lot of information. Right away, I notice angle A is congruent to angle T. Both are 47 degrees. I notice angle B is congruent to angle U. Both are 103. And then side BC is congruent to side UV. So in that case, by angle, angle, side congruence theorem, triangle ABC is congruent to triangle TUV. Now a more formal proof is example 3. They gave us parallelogram PARL with a diagonal PR. They would like us to prove triangle PAR is congruent to triangle RLP. So, as always, start with the given. Then they stated AR was parallel to LP and AP was parallel to LR. That comes from the definition of a parallelogram. In step 3, then, because we had those parallel sides, they were able to look at the alternate interior angles theorem for angle APR congruent to LRP and angle ARP congruent to LPR. Then you're able to say PR is congruent to itself, or RP, by the reflexive property of congruence. And then by angle side angle congruence theorem, triangle PAR is congruent to triangle RLP. And then the last theorem we're looking at today is the third angle theorem. Third angle theorem states if two triangles have two pairs of congruent angles, then that third pair of angles is congruent. So if we know two pairs of congruent angles, then the theorem allows us to say that third pair has to be congruent. So a proof of the third angle theorem is our final example. It's already filled in for you. Just had to highlight or underline some of the pieces. So what they want us to do, they gave us triangle ABC and DEF, and they told us angle A was congruent to D and B congruent to E. They want us to prove the third angle theorem of C congruent to F. So start with the given, then saying the measure of angle A equals the measure of angle D, and measure of B equals measure of E is the angle congruence theorem. If things are congruent, they have the same measure. Then the triangle sum theorem states the three angles added up equal 180. So what they did is they used the transitive property of equality to say if both those equal 180, then they equal each other. Then they substituted by replacing A and B with angles D and E. That allows angle D and E both to cancel by subtraction, which is also the additive property of equality. So here they're showing you what they did. And then that leaves us with measure of angle C equals measure of angle F, which means angle C is congruent to angle F from the angle congruence theorem.